Assalamualaikum. My name is Zurin Alisa. I would like to explain about the meaning of differentiation. Differentiation is the process of finding the derivative of a function. The derivative shows how a function changes as its input value changes. It is usually denoted as x. It tells us the rate of change or the slope of the curve at any point. For example, if a function represents distance over time, the derivative tells us the speed, like how fast the distance is changing. In this way, differentiation helps us understand how one quantity changes in response to another. Differentiation is an important tool in mathematics or science or engineering to analyze the motion, growth, and other changes.
My name is Najiha Safia binti Muhammad Razi, and today I will explain about technique of differentiation. Technique of differentiation has several rules, which is one of the rule is power rule. What it say is if you have a variable like x raised to a power like x to the power of n, to find its rate of change, you take the power, move it to the front as a multiplier, and then reduce the power by 1. Alright, for the next step is constant rule. Constant rule is, it say if you have just a regular number, a constant, by itself, it's not changing. So its rate of change is 0. As example, if you have the number 7, its rate of change is 0. It's not going up or down. Constant multiply rule. What it say is if your function is a number multiplied by something that is changing, you just keep the number there and find the rate of change of the changing part. Simple example, if you have 5x squared, that 5 stay, and you find the rate of change of x squared, which is 2x. So it become 5 multiplied by 2x equal to 10x. Number 4 is sum or difference rule. If you have a function that made by adding or subtracting other function, you can find the rate of change of each part separately and then add or subtract those results. Next is product rule. When you have two functions multiplied together and you want to find the rate of change of their product, you take the rate of change of the first function times the second function plus the first function times the rate of change of the second function. If you have x plus 1 multiplied by x squared, this rule helps you find its rates of change, where you has v and a function of x. Quotient rule. What it say? When you have one function divided by another function and you want to find the rate of change of the whole fraction, it's a bit more complicated. You take the rate of a change of the top function times the bottom function minus the top function times the rate of change of the bottom function, all divided by the bottom function square. Next is chain rule. This rule is for when you have a function inside another function. To find the rate of change, you find the rate of change of the outer function first, keeping the inner function as is, and then you multiply that by the rate of change of the inner function. Now, let's move on to question 2a. Question 2a asks us to find dy over dx for the following function. We are given y equal to ln e to the power of 3x plus 4 divided by x squared minus 1. First step, we apply the property of log, which is ln a over b equal to ln a minus ln b. So we rewrite our function like this. Y equal to ln e to the power of 3x plus 4 minus ln x squared minus 1. Second step, we differentiate both terms separately using chain rule. Let u to be e to the power of 3x plus 4 and let v equal to x squared minus 1. So dy over du equal to dy over du multiplied by du over dx. So u is e to the power of 3x plus 4. V is equal to ln x squared minus 1, but we write it like this, 1 divided by x squared minus 1. So to get dy over du, we multiply dy over du by du over dx. So 1 divided by e to the power of 3x plus 4 multiply 3e to the power of 3x. We get 3e to the power of 3x divided by e to the power of 3x plus 4 as dy over dx. The first term. So for the second step is differentiate the second term, which is ln x square minus 1. Let y equal to ln x square minus 1. So differentiate inside the bracket first. We get 2x. dy over dx equal to 1 over x square minus 1 multiplied by 2x. We get 2x divided by x square minus 1. So we combine the first term and the second term. dy over dx equal to 3e to the power of 3x divided by e to the power of 3x plus 4 minus 2x divided by x square minus 1. Next, we cross multiplication it, but no need to multiply it out. Just keep it as cross multiplication form.
Alright everyone, we are given the function. You can see the function in a circle. So we are asked to find its derivatives. This is a fraction of two functions, so we are going to use the quotient rule. You can see the quotient rule in a square. I put the quotient rule in a square, so let's set u and v. Now you can see u is a product of two functions, so we are apply the product rule. So let's differentiate x power 5 to get 5x4 and differentiate tan 4x using the chain rule. So we have u prime. Next, differentiate v equal to 1 plus x squared, which is give v prime equal to 2x. Now plug everything into the quotient rule. So that's our final answer. We don't need to explain everything unless required.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nuruliana binti Abdul Rahman. So my question is given 3 sin xy negative e power 2x plus y equal to x power 2. We want to differentiate both sides with respect to x. Step 1. Differentiate both sides. So for 3 sin xy, you will get 3 cos xy bracket x terms dy over dx plus y. And for e power 2x plus y, you will get e power 2x plus y bracket 2 plus dy over dx. For sin xy, use chain rule. Since xy is a product, apply product rules inside. So you will get 3 cos xy bracket x terms dy over dx plus y. And for e power 2x plus y, use chain rule again since y depends on x. So you will get negative e power 2x plus y bracket 2 plus dy over dx. So putting it all together and get 3 cos xy bracket x terms dy over dx plus y. Negative e power 2x plus y bracket 2 plus dy over dx equal to 2x. Step 3. Expand terms and multiply out the terms on the left hand side. So get 3x cos xy terms dy over dx plus 3y cos xy negative 2e power 2x plus y negative e power 2x plus y terms dy over dx. Step 4. Move term involving dy over dx to one side. Group all terms involving dy over dx. Get 3x cos xy terms dy over dx negative e power 2x plus y dy over dx equal to 2x negative 3y cos xy plus 2e power 2x plus y. And for the step 5, solve for dy over dx and you will get the answer is dy over dx equal to 2x negative 3y cos xy plus 2e power 2x plus y over 3x cos xy negative e power 2x plus y. So that's all. Thank you.
Assalamualaikum. Hello and a good day everyone. My name is Zurin Alisa binti Maliki. Today I will be presenting the solution to question number 4 from our Calculus 1 group project assessment. In our question, we are given f of x and the given value of x. We are asked to estimate the value of square root of 25 minus 2.9 squared. Instead of calculating this exactly, we use differentials to approximate the value quickly and easily. As you can see the yellow box in slide, it is a step to solve the linear approximation question. Okay, so for the first step is we have to choose x value. We are given the given value of x, which is 2.9. So we have to choose a value that is very close to 2.9, which is 3. For the second step, we are working with the function. The function is given, which is square root of 25 minus x squared. So we just need to simplify it into exponent form, and it will become 25 minus x squared to the power of half. For the third step, we need to find the derivative. By using the chain rule, it will become half multiplied by 25 minus x squared to the power of negative half multiplied by negative 2x. Okay, let me explain each part. In the function of f of x, which is 25 minus x squared to the power of half, half comes from the exponent, right? Which means we have to bring the exponent down and subtract by 1. So that's why it became negative half. Okay, so for the negative 2x comes from the differentiating the inner function, which is 25 minus x squared. So after that, we just need to simplify it. For the fourth step is we calculate the difference between the given and the chosen value. And we will get negative 0.1. Why do we do that? Because it can show how far apart the two x values are. This is important for the approximation formula. For the last step is we will use the approximation formula. I have write that in my slide, and then just substitute the chosen value, which is 3, into the x, and then we will get 4.075. Therefore, the estimated value of square root of 25 minus 2.9 using differentials is approximately 4.075 and correct to 3 decimal places. That concludes my presentation for question number 4. I hope this explanation was clear and helpful. Thank you for watching.